So this is another new paper that just came out in Science Advances just in March 2022. Talks about the rapid rise in premature mortality due to anthropogenic air pollution in fast-growing tropical cities from 2005 to 2018. So uses multiple instruments, satellites to track multiple pollutants and look at mortalities and attribution of premature deaths to pollution. So tropical cities are experiencing rapid growth but lack routine air pollution monitoring to develop prescient air quality policies. Here we conduct targeted sampling of recent, so 2000s to 2010s, observations of air pollutants from space-based instruments over 46 fast-growing tropical cities. We quantify significant annual increases in nitrogen dioxide, NOx 1 to 14%, ammonia 2 to 12%, and reactive volatile organic compounds 1 to 11% in most cities, driven almost exclusively by emerging anthropogenic sources rather than traditional biomass burning. We estimate annual increases in urban population exposure to air pollutants of 1 to 18% for fine particles, so that's PM2.5, which is very deadly. You breathe it in, goes into your lungs, into your stomach, into your bloodstream, into your brain also, and 2 to 23% of the NO2 from 2005 to 2018, and attribute 180,000, so 95% confidence interval there, going from minus 230,000 to 590,000 additional premature deaths in 2018, so 62% increase relative to 2005 to this increase in exposure. These cities are predicted to reach populations of up to 80 million people by 2100, so regulatory action targeting emerging anthropogenic sources is urgently needed. Two things. One, you know that generally maybe you figured out that I'm a bit hesitant to talk about alarming messages from projections of 2100 because model uncertainties and scenario uncertainties often make it difficult to know how much to emphasize those future projections, especially from models that do not capture the past very well, like for monsoon trends, for example. Secondly, developing countries which keep saying historically developed world is responsible for global warming, so they should pay for it, cannot escape out of this one because these are mostly activities that are related to their own anthropogenic activities, economic growth. It's not like they're doing something wrong, it's just that they're not tracking pollution and moving fast enough on reducing pollution. So that's a separate issue. Plus these projections of population are problematic, and hence the projection of exposure numbers for 2100 also is something I wouldn't emphasize too much right now. But the historic data is always good, so looking at past data and conclusions drawn from there are always very valuable and should be used to drive policy decisions and actions to reduce emissions and protect people, right? So we are looking at baseline NO2, 10 to the 15 molecules per centimeter squared. You can see the scales in different sized circles and the trends in percentage per year. Here mostly the warm colors are all positive, so there are some regions where there are negative trends. One has to see what other details are there and what other pollution is going up. For example, there is an increase in ammonium here, even though there is a decrease in HCHO and NO2. Okay. So you can see that the tropics are dotted with lots of positive trends over this period of 2008 to 20. Sorry, these are different time periods, but it doesn't matter. So the non-methane volatile organic compounds are for 2005 to 2018, ammonium for 2008 to 2018, and so on. So main point I would want to leave with is that Ammonium here is showing largely negative trends, maybe a slight positive trend here around Mumbai. So we are only looking at cities. So this should be maybe Bali, shouldn't be Jakarta. Jakarta should be up here, and the various other cities. And China is not included in this for whatever reason. It doesn't matter. West Africa and East Africa, Southeast Africa are quite prominent in these trends, which is of course bad news for developing countries. Okay, keeping that in mind, if you look at aerosol optical depths from baseline MODIS in terms of trends, again there are a couple of places where there are negligible or small negative trends, some large negative trends around here, and largely there are positive trends, especially over big cities of India. I think Hyderabad, Bangalore, Chennai, Pune, Mumbai, whatever this city is, Kolkata, Berhampur, Dhaka, and so on and so forth. Okay, so this is a proxy for PM2.5, particulate matter 2.5 micrometers large, which is very small, so you can easily breathe it in without even realizing you're breathing it in. So this abundance in rapidly growing cities in the tropics for 2005 to 2018. Circle colors are of course relative trends in AOD, and sizes are values at the start of the record, so baseline. Outlines identify significant trends at 95% confidence interval. Warm colors indicate positive trends and cool colors indicate negative trends. Cities with poor temporal coverage are gray here in Africa. Should be something in Kuwait or Saudi Arabia in here, maybe Riyadh or whatever. So looking at PM2.5 exposure trends, which are defined as the population, that is population density kind of thing. So trends in exposure to air pollutants hazardous to health in rapidly growing tropical cities. Circle colors are trends in exposure to PM2.5 in A. B is NO2 and yes. Okay, so this is PM2.5, and to NO2 this is population growth, so that's what changes the exposure in percentage per annum in those big cities. And you can see again mostly all either red colors, warm colors, so increasing exposures in population numbers, or there are places where there is not good enough data, or this color also is where the scale is beyond 24%, which is massive. These are gray colors here are where there is no data. Okay, so bad news all over. Cities in the tropics have rapidly urbanized, economic activity is increasing, population is increasing. Cities are magnets for migrants seeking employment, and they are also hubs of financial activity, innovation, number of patents filed, and so on. So there are lots of pros but lots of cons as well in terms of clean air, living quarters, access to healthcare. So even within a city, a heat wave, for example, will have very disparate outcomes in slums and poor neighborhoods versus the richer neighborhoods, and the gradients between the rich and the poor can be very sharp. Okay, so looking at increase in premature deaths from 2005 to 2018, the total numbers here is about 179,550. So that's the 95% confidence interval on the negative and positive sides. Increase in premature deaths due to increase in exposure to PM2.5 here in rapidly growing tropical cities. Bars give the increase in premature mortality in 2018 relative to 2005 for the top 15 tropical cities, colored by the percentage point change in fraction of premature deaths attributable to exposure to PM2.5. Inset value is the total for the cities in Figure 1, which we just looked at, which was a population map with detectable trends in aerosol optical depth, which is a proxy for PM2.5. Values for all cities are given in a table in supplementary material you can look up, and the relative contribution of individual factors like PM2.5, population, excuse me, and baseline mortality are also provided in supplementary material. Okay, so there are negative percentage changes in attributable fraction in places like Bangkok, Ho Chi Minh City, and Hanoi, which we already saw here, for example. And rest of the story is pretty bad here. 15 percentage points from 2005 to 2018 for PM2.5 deaths in Dhaka, which tops the list at 25,000 in increase in premature deaths. Mumbai, Bangalore, Kolkata, Hyderabad, Chennai, Surat, Pune, Ahmedabad, so these are negative, and then you have slightly positive like in Sasha, Jakarta, and Lagos. So that must have been Jakarta where I said it may be Bali. Okay, so you can see that the story is not good at all. Urbanization has advantages in terms of generating employment opportunities, supporting livelihoods, and so on, but comes with lots of climate change issues, climate impact issues like urban flooding, extreme events, but also big impacts in terms of air quality, and access to mitigative measures like air conditioning or public transportation is obviously not always accessible to the working class or the poor people in the urban centers. So all those factors require careful mitigation measures as well as policies for the future if populations are expected to continue to grow, which will happen. Urban centers will continue to get more and more crowded in the coming years and decades, even though I would put a caveat on projections for 2100 because the fertility rates are dropping and actual populations may also be dropping even in country like China. Okay, let's leave it there.